Thank you for having me. I am Marcelo. I will present to you today with a talk on how to build your own Uber app. I worked for a big company back in Brazil called SydPHP, then The Iconic, then Offload, and now at Insight. Recently joined last week, so pretty new. Yes. So yeah, Insight, so just a bit of background on Insight, it's optimizing efficiency through data visualization. They have, well, we have now, I should say, proprietary IoT devices that collect data from the ground through trackers, sensors, and network. So pretty cool stuff, so check it out. We're in the agri space. There's a lot of things, and conversations there are wild. So yeah, a little bit on SydPHP, so just you have an idea, because it's a Brazilian company, but it was really at its peak present in more than 30 different countries, including South America, all South America, Indonesia, Middle East, Taiwan, Hong Kong, Singapore, just to name a few. It was much better than Uber. It was, it doesn't exist anymore. Yes. Think about it like Uber for taxis, like 13 cabs or Ola. So I'm here to tell you how to build your app and then tell a little bit of the story of how we did it. And talking about data visualization, this is essentially, I think, a month worth of travels from different drivers in different cities. And we had this project where we're able to collect all the GPS positions where they have been and light it up as, you know, in black canvas. And surprisingly enough, it ended up drawing the city limits pretty nicely, right? So there's no map involved, it's just data. So it's pretty cool, just to start. So all you need is essentially three things. So you need two mobile apps, one for the passenger, another one for the driver, and an API. We use Alex at the time, micro framework for APIs, so it doesn't have all the loaded thing for doing UIs, it's just API driven. And the device that collects GPS position. So what are we actually trying to solve, right? So, well, see, the passenger, you as a passenger, right? So you're in the street and you're trying to find a driver that's available and that is closer to you, but you actually don't have an easy way of calling them. So it's pretty annoying, right? So that's exactly what you're trying to solve here. So how do you connect those two parties? So essentially, the first piece of the puzzle is to create a driver app. And that's, you create a driver app to address this issue, and you distribute to all drivers in the city. Easy peasy, right? So that's very easy to do. Then you start collecting the GPS position of those drivers. So how does it work, right? So you have the app getting the GPS position, you collect the latitude, which is essentially the x-axis, then you collect the longitude, which is essentially the y-axis, and then you send back to our server, right? So we store all these positions using MongoDB, which MongoDB is a NoSQL database. Given the structure or nature of the data structure that we were collecting at the time, also we wanted to leverage speeds because MongoDB was lightning fast, or maybe blazing fast. Yeah, so we collect this on NoSQL database because also multiple different countries, so we had to have different configurations per country. So it made a lot of sense to do this in a NoSQL database. And this is essentially saying, you know, like, how do we collect data? And then all you need to do is if someone needs a ride, actually, sorry, the app as well, the driver needs to know if someone needs a ride, right? So and the way for them to know if someone is looking for a ride at that moment is using a technique called HTTP polling, right? So essentially every 15 seconds you go to the server and ask, right? Do we have a ride? Is there anyone that needs a ride? And together with that information, every 15 seconds, sorry, you would also send in the headers as extra information the GPS position, so you know where that request is coming from. Sorry. So essentially what you have, it's something like this in your database, right? So that's how your database looks like. And then the driver is called back again 15 seconds later, and then you have another snapshot of the database that they will look like this 15 seconds later. And then since we actually don't care much about the previous positions where they were, because they're not there anymore, we use a command from MongoDB called upsert that will replace or insert a position of the driver in the database if it's not present. Pretty simple. So that it's essentially it for the driver app, right? So you need the polling and you need to know the positions. Now we go into the passenger app, and so you need to have a way for that passenger to call those drivers, and that's our beautiful passenger app on one of the latest versions. Many features packed there. So yeah, why not creating another app and then have every customer to install in the city? Pretty easy job. And then they press a button, the drivers pop up. And the way that you do that, it's very similar technique, right? So that's why it's a repeated slide here. That app also gets the latitude, the longitude, sent to our API saying, hey, I want to ride in this location. Please send me one. But now the brain, the API needs to actually find a way of searching for the drivers, which is the most suitable one. So similar. So how do we actually, search for a driver? So this is, what the passenger app would see. Would see all the drivers. We had different icons that we would use. That was an Star Wars event, so we would push releases to have different icons, which was pretty fun. But then how to do that? Right, so your database now, your situation now is looking a bit different, right? So you have all the drivers' positions, and then you have a special one now that is the passenger position. And then you want to search for which ones are closer to that red dot. So then back to our geometry class. The easiest way to find all the points equidistant to the origin is to define a radius from the passenger in the middle, trace a circumference, then find if the other points are inside that circle, so the passenger in the middle, right? So you define the radius, press this. Man, I panicked, right? So I don't even know where to start. I don't remember how to do that. So that's where Mongoose comes in, right? So Mongoose and its geospatial query system actually does it really easy for you, right? So we have a collection. Mongo would call it collection, also known as tables. So a collection of positions, and you essentially say to that query to locate in that collection any other points that are near to this location. You set the maximum distance, which is the radius that you want, and then any other extra criteria as well, like types of drivers, right? So you have Uber Black, for instance, right? So then you limit that search and other criteria that you can add there. And that's it, right? So then you get easily all the points, all the positions, or essentially all the drivers that are close to that passenger. So let's call this our strategy. So we used to call like a straight distance strategy. So just advance a bit. Straight distance strategy, because it gives us, when I get the result of this query, it will give us the distance to that point in a straight distance, right? So that's the simplest strategy that we can do to find suitable drivers. And then it will give you a result like this, where you have the distance and then it's sorted by distance, the closest one, and then you can store that information in another collection where when the driver requests the server, right, is there any ride? So if he is in that list, then you send the ride to that driver in the response. So now, while the passenger, the API is calculating all this, the passenger app goes into this polling mode, right? So it keeps asking the server, do you already have a driver? Right? Did you find a driver? Find a driver for me. Is it ready yet? But then we keep this searching for a driver, or we time out essentially, because we cannot keep searching forever. And that's it. Right? So that's essentially what you need to create, like all the main elements of this app. So from here on, it's not quite. So there's a lot more, but it's not super structured. But I was planning to just give you a little bit of overview of some real-world issues that we face. And to see how are we on time? Am I rushing too fast? Yeah, good. So if we have time, then we go into this. So in this process where the passenger is trying, the time is of essence, right? So so getting back to our straight line strategy, offer strategy, straight distance offer strategy. So we haven't defined the value of R before, and then clearly, of course, the best value is closer to 0, right? But then closer to 0 might give you a result of 0 drivers. And then if you go too big, then you get drivers that are super far away from the passengers, right? So which is not a good experience because they're too far. So we figure out that this also varies a lot along the day. And in rush hours, a bigger radius might result into many drivers, right? So you put it big, it's super packed, so you get a lot of drivers. And then alarming and then sending requests to 100 drivers, for instance, will annoy everyone because they only have 1% of chance to get that right? So only one driver can accept. So this impacts how the passenger and the driver perceive our platform. So we have to play with those KPIs all the time: acceptance rate, how many drivers we are actually offering to, how many rides the driver can actually accept, so they can actually feel that you have a platform that is good. So the solution for that problem was essentially having a function that takes into account the day of the week, because every day is different, and then there's a behavior that is different in the city. The time of the day would also make a difference, right? Overnight, it's very different than like a normal working hours. And the distance and the ETA, which is estimated time to arrival, and the quantity of the drivers available as also taken into account. And then we created an algorithm that was called progressive radius, right? So it works like this: you set a maximum radius, like the biggest one you think you need to get to cover that city or that region, and then we check for tiers. So we create tiers, and then we first do, can't see the tiers, right? So you first do send a message to the drivers that are in the first tier. If there is none driver, you immediately go to tier 2, and then you wait a bit, right? So you give it a couple of seconds. You don't have much time. Again, it's of essence. No one accepted, you extend to the next one, so on and so forth. And to do that, we end up storing this configuration, right? So lead time, distance, the time that was valid for the weekday that was valid for, so on and so forth. So let's look into another situation, right? So another problem, or another challenge, I would say. There is this driver. So it turns out that straight distance offer strategy, it's sometimes inefficient. I hope you can see it here. So imagine that driver 1 looks closer to passenger, right? But actually, in reality, driver 2 has actually a better route to get to that passenger fast, right? Or faster, right? So then your straight distance algorithm essentially failed. So we are forced to create a different algorithm that is based on the route, right? So we would call it like route-based strategy. But this is not something that you can get out of MongoDB. It takes a lot more time to calculate the routes for every single point that you have. And every second that you spend doing calculations throughout this process, it's time that the client and the passenger is waiting for the driver to be assigned to him, right? So not taking into account for how long the driver will have to take to them. So we compromise, we combine the straight distance algorithm, we do a limit, we get a limit that is reasonable, that has more chances to get to that passenger. And then with that limited database, or data set, we then do a calculation using Google Maps or here Maps now, I think they're called. I think before they're called Nokia or something. So this is an isoline that is distance-based, right? So essentially, any point on the boundaries take the same distance to get to the middle one, right? So en route, right? So trying to figure out the routes in the city. But you know, life is full of surprises. On rush hours, this doesn't work well.
How do you work this out?
This you do, it's another query. You send, that is an API. You send a query, you say, this is my middle point. This is my distance. What is the area that you actually have in route distance? That's Google or Here Maps. Both offer this option. Here Maps, here, yeah. So rush hours, this wouldn't work well. Then we were forced to move into another strategy, which is like an ETA-based strategy, based on traffic, on time to arrival to the client. And then you can see that the shape of it's the same parameters, but the shape of the area changed completely, right? So you're not going more straight lines. It's not days, it's actually how long it takes for anyone inside that area to take to get to that point in the middle, based on traffic and time, right? So whatever it's inside is taking less than the maximum time that you defined. And then we initially thought that you know, drivers would, like, the first driver to accept is actually the one that takes the wins, right? So it takes it. But remember the polling strategy or technique, right? So it takes 15 seconds for you to, for a driver app to notice that there is a ride. So that will then get the drivers to find a better mobile phone, so they could, you know, have a fast phone, better 4G network. At that time, they were like even paying more to get 4G because more like as faster your internet is, the better you get the data. But still, you would have gaps. So we would send a ride for you, but then the other app is still polling, right? So it would take 15 seconds. So you accept, and when it gets to him, it's gone, right? So we end up using, and then drivers got really annoyed. So they come up with this solution. So we had, I don't have the icon here because I got the, you can see here you have accept and reject, right? So at some point we added the reject point. And at some point in time, that's a newer version, but the accept button, it was like a big button in the middle, right? So the mobile device would go into background, so essentially close, right? So it will be off. They'll put the rubber band, and then whenever we bring the app back to front, to forefront, it would just click automatically. So we had a lot of issues of driver automatically accepting, and then they would think, oh, now I can cancel, right? So, and then that's another KPI we had to look for, like how many drivers are actually canceling, and that's why you see penalties on Uber, etc., because it is a behavior that happens. So it's actually a very interesting technology, I think. I'm not super up to date into this, but we use PubNub to solve for those issues. So PubNub, it's a publish-subscriber network, so they have infrastructure across multiple countries. And they essentially are an event-based, event-driven platform, right? So you get an SDK, your app connects to PubNub, and essentially opens a WebSocket that's prior to HTTP 2, right? So I think you can do that, achieve that with HTTP 2 nowadays, but it's still, they have distribution, right? So they have a network. So then instead of the driver polling, we would then push the information to that app. And that would reduce, like whenever we have a ride for driver from 15 to 2 seconds, right? So that made things much better. And of course, we changed the UI so they could avoid of doing this. But if you could think, maybe you remove or you change the polling time to be a shorter one. But if you do change from 15 to 5, you essentially create a DDoS on yourself, right? So you if you have, we had 50,000 drivers send a request every single minute. So and then that's because they have every 15 seconds. So if you reduce that, then you double, triple, quadruple that, and that kills your server, right? So it requires more servers for you to process. So we call those guys fast fingers, right? Because they would just accept. But then at some point we realized that this was also not a super reliable option, because drivers is not usually the first one that accepts that is the best one to get that right. Sometimes they're not super close. Sometimes it took a long while for the closest one to accept. Then we come up with this auction strategy, right? So which would allow more time for drivers to be able to accept. But that I will let you to imagine how you can actually achieve that algorithm. But that's it. Thank you. Questions?
Said that your company was better than Uber, right? So
Yes. What happened? Cool. History. Uber entered the Brazilian market, which was one of the biggest ones for us, also South America. So we were first players in some, second player in other markets. Uber entered, and we had to push and then change processes and then innovate and then be the best app and then go private. We entered into private cars as well, private drivers, to essentially offer the same thing. And then we pushed the taxi drivers to actually lower the cost as well. And we had internal conflicts of raising funds and being acquired. So we were supposed to be acquired by Didi. but that was the C-levels blow out that deal. We end up being acquired by Cabify, which is a Spanish, I think Spanish company. And they essentially replace the app, release, and they screwed it up. They thought that the technology was better. And I've been talking to the team after that, and then they say like, "Oh, our technology is much better," but they actually don't know how to deal with that. And then usually the company that acquires comes and then raises everything. Yeah, and they exit the market, so they end up failing, and then they're not there anymore. So the company is dead, unfortunately. Yeah, so that's why I can show you everything, because no one will chase me.
Well, thank you for your presentation. As a language, have you faced any challenges using PHP as the main programming language for this kind of project?
Yeah. So the question is again, right? So on PHP, is PHP a good language for this? Is there any challenges on this? I have to say that PHP is a great language because we were using PHP 5 at that time, and then we upgraded to PHP 7, and it was super fast, right? So we had response times with Mongo as well, and usually you have issues in the database. The database starts being slower than your code, but then again, your code matters, right? No matter what language it is, your code matters. So yeah, we've been super, especially we had APM everywhere, so we wouldn't know which requests or transactions are taking longer. Focus on that and then optimize those, and then try to take out any single bits that we could from that code to speed up the process. Putting database in memory to speed up how long we would write the data. But then, of course, you have to think about the use case. You can't use any solution for different use case, right? So anything has drawbacks. But no, PHP is great and fast. Woo! What payment gateway we were using? So we're using Adyen. I don't know how to pronounce Adyen. Yeah. Adyen, it was the main one. But very interestingly, right? So on the taxi driver, we had, and then Uber pushing us, we had to create our own taximeter. So we had to calculate everything offline in the app. We would have to do offline payments. So when you leave the Uber and then you shut the door, you don't care, right? So before we were like, oh, you have to end the ride, you have to wait for the payment to process, and then when it's okay, the taxi driver can let you go. There was a lot of trust issues, but then when Uber entered, it was like, oh, Uber is not like that. Uber is seamless, so you don't care. So yeah, we had to create all this whole thing of offline payment, which means that payments wouldn't be processed immediately. So we had to do pre-approvals and then trust and then keep trying, and you have network issues that the app might not connect to you for a long while. The driver might log off for the day, and then when it logs back, you have to catch up with all the processes, all the payments, and then reprocess, and then reconcile, and then make sure that you pay for all the rides that because you have the rides, you just don't have the payment data, have to reconcile and then figure out. So it's a big, and then you go into fraud detection, there's the whole thing.
Which other technologies have you used for this regarding the
Cool. So which technologies, what was tech stack essentially, but in detail. So we use LAMP, right? So LAMP architecture. Excuse me. So Nginx for sure, AWS with auto-scaling EC2s at the time. The apps had to be native, so Android and Swift, I think, at that time. What else? Database, MongoDB, mostly, especially for sharding across different regions. and out, how does it call? So you have replicas, right? So you can't do that really easy on PHP. So replica sets, it's much easier to deal with MongoDB. So you could have 3 replicas and then they would fail over. If someone fails, then the right authority would go to the other database. So you would always have these redundancies. And MySQL as well, when we were doing payments, we wanted something more transactional. Postgres was not in our radar at that time, unfortunately, so we used MySQL. What else? I think that's mostly it. And then service providers SDK from external APIs.
Any
Cool.
more questions? Leave it up in a minute.
Cool. Yes. Thank you.